this is a different kind of lecture today you are going to face. Because all over India, our classroom teaching is such that teacher comes and whatever you want to deliver, either he or she go on talking or write on the blackboard. And mostly what happens, after 15-20 minutes, most of the students fail to follow what is happening. Even in the next day when they come back, if we ask them what has been taught last day, they cannot answer. Reason is very simple. Because you have not done anything by yourself, you have not read by yourself, you have not even seen the book earlier. But this lecture is something different because I am not going to teach you, but you will learn yourself. This is completely a different kind learning. This is not a rote learning. You know what is rote learning? That committing in memory, vomiting on paper, and you all get 100% marks in your final, and then you are admitted in engineering colleges or in medical profession, and when you go for a job, then they say you are not suitable because you don't know anything. This is not applicable for everybody, but majority of our students is suffering from they are unable to get a job because they are not competent enough for the job. But they are good students, they get high marks. Then how to rectify that? That is why all over the world, the first country, the developed country, they have a different kind of teaching where the students are shown something and accordingly students try to understand what is happening and they give their opinion, then teacher corrects them. I give an example, very interesting example, which I recently heard that in a class 3 in a China school, students were given raw egg. And what they were asked that you go to the first floor and drop the egg from there in such a way that when it drops on the ground floor, it will not break. And you are given some amount of, some ropes, some pieces of papers, lots of were given in the class, and the result is fantastic. I was really amazed to hear that even you students, you may be in class 10, 11 or 9, I don't know, but all of you, if I give the same task to you, I think you will fail. What they have done? Most of the students, they innovated certain things. And then after doing that, all the students dropped their eggs, and believe me, 50% was successful. The raw eggs remain intact. This is called innovation. That means the students thought that when an egg falls on the floor, why it breaks? So we have to do something so that the egg will not break. Whatever they have done, our objective is not that. My first lecture is regarding the pressure. But I think you know what is pressure, but even then I am asking you, what I am doing? What I am doing? Tell me. One at a time. Raise your voice.
Applying pressure.
Applying pressure, right. Now you see, I have an instrument. You see that this instrument has a ordinary plastic tube or polythene tube, and you can see there is a liquid given in this. Now I am closed this, and I am doing the same thing as I have done in my body. I am applying pressure. Good. What happened? Look at the YouTube. See? What happened? When pressure is applied, YouTube reading changes. Right? Now there is some water in a glass. And interestingly, I put some scale over here that the height of this water is exactly 10 centimeter. Now you see what happens when I dip this tube in this. Look at the labels. What do you find? One at a time. Raise your hand loudly.
Level is rising.
This side is going down because this pipe is. So who is giving the pressure?
Liquid.
Liquid giving a pressure. Acha, now carefully look at it. I am going down, down, down. What do you see there? The pressure increases. When I am coming up, decreases. So our two understanding we have already done. The first understanding is, tell me, what is the first understanding?
The rise of high pressure
Liquid exerts pressure. If it is not water, if it is milk or any other liquid, it behaves at the same way. That means liquid, this liquid can be anything and this exerts pressure. So by this tube, we are proving that, and that as the depth increases, liquid exerts pressure, and with depth, what happens?
pressure increases.
So first understanding, liquid. Second understanding, right. Now you see, I just bend it. Is there any change?
Yes.
You see the tube is facing upward. Okay. Now I am just putting this towards you. Is there any change? There is a change. I am taking this in the backward direction. Is there any change?
Yes.
Is there any change? That means the tube is open on that side. I am taking it on this side. And also in the upward direction. Does it giving pressure difference? So you see, the third understanding is that the pressure is exerted in all directions. Very good, very nice. Now I go to the bottom of the glass and I put my finger over here. Now I am rotating this. At the bottom of the glass, is there any change? Can you see the changes? Is there any change? Then what is our fourth understanding?
Pressure is same at a particular depth.
Pressure is same at the particular depth. So you see, on the liquid pressure, we have understood very important 4 points, normally which is being taught in 3 classes or 2 classes. That is, first is liquid exerts pressure. You have seen it. Liquid exerts pressure from all direction. At the same, as the depth increases, pressure increases, and when it is at the same level, the pressure is constant. Now, I am always talking something, pressure in this direction, in that direction. Am I talking right thing? What I mean to say, does pressure has any direction? What is your opinion? Is there any direction for pressure? Then how can it be that when this tube is at the bottom and I am moving in different direction, they are giving the same reading? That means the pressure is same. Then how it can be related to a direction? If I give you a blow, which direction it will move? In the direction of the force, right? So in the direction of the force, if I give a blow, it moves. So it has a direction. But pressure, it doesn't have a direction. So let us do another experiment. We keep it suspended for the time being. So the first understanding from our part is that liquid exerts pressure. That's all. We have no qualitative thing but anything. Now I want someone of you come here and do an experiment with me. Can you come? Anybody? You come? Take some water. Show your friends. No. Full water. And hold like this. Like this. You feel the weight?
Yeah.
You put in water, but do not dip inside the water. Go on going down. Do you feel the same weight?
No.
At all you are feeling weight?
At a point, no.
Almost no.
Almost no.
Again take it up.
I feel the weight.
Feel weight. Again you go down. Do you feel the weight?
No more.
Tell your friends. You
Yeah.
don't feel weight.
No.
When you are water. Now you take it up. I am holding you. Do you feel weight?
No.
Why you would not feeling?
Because the force is being applied from downward.
In the upward direction.
In the upward
Force is applied in the upward direction. Then in liquid, there must be a force acting in which direction?
Upward direction.
Upward direction. You understand that?
Yeah.
Okay, go back.
Thank you, sir.
So we see any object when it is put inside a liquid, its weight decreases. This is a strange fact because we know gravity is acting downward. Any object, I have certain objects, these are my objects, and you can see all these things are very cheap thing. This is a empty honey container. Now these are certain objects with me. Why it goes up? Because I apply force in which direction? Upward direction. Good. Have I taught you that I gave a force in the upward direction? Have I told you? How you said that? Because you see. Seeing is believing. When you see something, you believe. Now you see, I take this inside this, I go down, release it. Why it has come up? There must be a force in acting in the upward direction. You see, I release it, I am not holding it. I just release my hand and it goes up. So there must be a force in the upward direction. This property is a very strange property of all liquids, that whenever an object is put inside a liquid, a upward force is acting. And as my name is B.N. Das, like that, that upward force also has a name that is called buoyant force or buoyancy. Will you forget it? Every liquid exerts a pressure in the upward direction, which is called buoyancy. Very good. Now, but how much force it applies? Let me show you something. This is a nice piece of stone collected from Pahalgaon. I have a very peculiar habit, wherever I go, if I get something very nice for my experiment, I collect it. So you see, this is a very beautiful looking stone, and I am not going to worship it like Shiva, but it's a stone for my job. What is the, what is the weight? Let me see. Do you know what is this? One at a time, one at a time. This is a? What is the reading? One of you come. You come. See what is the reading. The index, below the index, what is the reading? Come forward.
25.
The index is here.
Oh, 0.
So you see, you are a senior student, even then you say it is a spring balance, but you don't know where to look at. Why it is so? Because you have never got a spring balance in your hand, isn't it? Have you seen a spring balance in your hand?
Yes, I've seen.
You have. Then how can you not? Huh? Ajay, let me tell something, that if I turn it over and hold it, will there be any reading?
Yes.
No? Yes. Why yes?
Because this.
Now I am holding the spring and the weight of this body giving a reading. So what is the weight of the body?
0.25.
0.25 means 25 gram. So this is 25 gram. Now you see, it has changed certain things. Let me say, now it is again at 0. Okay? Now take that stone and hang it. If you break my stone, I am not going to break your head. Okay? How much is the weight? Let me rest my body so that
0.76 Newton.
no, don't say Newton, forget about this.
76.
How much division? This is
5.
5, 10, 15 and then 1 division, 2 divisions because below the index we are taking the reading. How much is? 17 division,
Yes.
5 gram each,
80.
85.
85.
Sure,
80.
80. Okay, 80. Now, students, if I put it inside water, what will happen to the weight? It will decrease. How do you know? Because you have learned that when we put something inside water
And up.
or any liquid, then upward force is there. So, you see how much weight is lost. What is the weight now?
45
Don't say 45,
grams.
45. Previously it was 80.
50.
No, I am resting it. I should not touch.
50 grams.
Each division is 5 gram.
50.
First you say 50. Okay. Then loss of weight?
30. 30 grams.
Clean 30 gram. So, you write with that pen on the board just at the center that loss of weight in water is 30 gram. Weight of the stone is 30 gram. Equal to, just write in water. Now, where from this 30 gram comes? You keep the board. Now, what we are doing, I am taking this container and fill it completely with water. And you really do not have any idea what is called completely filled with water. Maybe you are thinking that it is completely filled up with water. Maybe. Now, all the water is poured down. I put it here. Give me the syringe. Oh, okay. Now, I am going to put some water on it. Do you follow, students, that we have weight that stone, this stone, weight is 80 gram. When it is dipped inside water, then it loses 30 grams of weight, 50 gram is its apparent weight. Why apparent weight? Because earth is pulling the stone with the same force which was previously applied. Now, there is a second force which is applied in the upward direction. Okay? So, I am now filling it up. You just take care, see that whether a drop of water is coming out or not. See how much water is coming. I am adding, still I am adding. Now, how the surface is looking? It is looking like this. So, then how it looks? The surface is like that, but still it holds. Be carefully that so that no water falls down. Is there any drop came out? Is there any water drop came out? No. See the shape. Still it will take more water. Give more water. No drop came out. So, this is called completely filling a container. Normally what we say completely filled, it is not completely filled. So, you see so much water can it take, and that is why some experiment you show that in a glass of water you go on adding pin and water is not coming out, because it is not full, that is why it is not coming out. Okay. So, I am going to put more water, more water, more water. Is it falling? Be careful. Tell me stop. When a drop of water come out, will tell me stop. My God. So, a drop of water came out. Now, we can say this is completely filled up with water, and what is the shape of the water surface? Like this. Very good, nice. Now, all the students, I am asking you, if I put this stone inside the container, inner container, how much water will overflow? How much water will? How is it related to this? When I shall drop it, how much water will come out from that container? Equal to?
The loss of volume. Equal to its volume.
Equal to its volume.
Equal to its volume. That is, whatever its volume, the space it occupied, that is its volume. So, it will throw away the amount of water which is equal to this volume. So, you see slightly more water because previously one drop of water has come out. Now, what I do, I just throw all the water from it. There is no further water. I take it inside this. How much water is this?
Equal to its volume.
Volume. Very good. Very nice. You are looking at this. So, as you are looking at this, you know what is happening. Can you do this at your home? Very expensive now?
No.
You can get it. Okay. Now, weigh this. Tell me what is the weight. Is it 0? 0 is okay?
Yes.
Very good. I am not looking at it. It is your how much?
50 grams.
50 gram. Now, if I get the weight of that water, what I am to do? What I shall do? This is a container plus water equal to the.
Weight the container first.
No, already I have weight container and water. Then what I should do? I should
Take out the water.
take out the water. So, we get
Only containers.
only container. How much? 20? 4th division?
No, 2.
2. No, it is 3 division. See? 15. I always say that below the index.
Then 15.
15. That means its weight is 15 gram. Then how much is the weight?
50 minus 15
Huh?
is 35 grams.
And 1 or 2 drop was extra fall down. So, our loss of weight of the stone in water was 30 gram, and approximately we get the weight of the displaced water by this, whatever its volume is almost 30 gram. We could not prove it because of the extra weight which has fallen down. So, we get that the loss of weight is equal to the weight of the displaced water by this object. This principle someone has discovered long back before Christ. You know the name? You know the name? Archimedes. Wonderful. So, you have learned Archimedes principle without telling what is Archimedes principle. So, thank you very much. Take your seat. So, now we see that how much time we have taken, maybe 15-20 minutes, and what we have learned, that water exerts pressure, it increases with the depth, it acts in all directions, and at the same level it is equal. Then we have taken a object, put it to water, weighs it, what is its weight in water, what is its weight in air. So, from that we get the difference, how much weight it has lost. Then what we have done, we weighed the amount of water it has displaced, and that water happens to be same with that of the loss of water. This is called Archimedes principle. Okay? You understand.